Hey, good to see you. Welcome back, and I'll just dive straight in. So, as I mentioned previously, we're going to be looking at artificial chemistries, right? So, with the idea behind artificial chemistries, similar to the idea of artificial life, is you use a simulation to represent what happens during chemistry. Now, the principle of where artificial chemistries is its own thing comes from a simple premise. In artificial automata, there are certain rules around the systems that perform the functionality computation, right? So basically, artificial chemistries are based on a computational method for providing results in a system that has a language that is based on that of chemistry. So basically, we use the language of chemistry and we provide computational algorithms to create results that can simulate chemistry. That's basically it. And the magic comes into play really with a very simple transformation. And so I can describe to you what artificial chemistries is. You know, I'd like to call it computational chemistries, but that aside, let's just talk about what the main reference, the main term, the main definition, artificial chemistries, right? So in computation, there's generally an operation that performs something that is computed, and there is a result, an outcome. So basically, what we do here in artificial chemistries is, if you look here, you'll see the notation for a uh, simple computation, right? So a plus b equals c. Now, the difference, the moment we move into something else, is like this is a bit of an eye opener, a bit of a not a game changer, but it'll change your perspective about how you can use computation to perform different things in different ways in different systems. So all we do with this is we go and do this, right? We change it to the following. Now, what happens here is that we have a different type of notation. And the system performs differently in the sense that, we don't use necessarily integers, but we use these concepts and we put them together and we get a result. But it's a process, it's a chemical process in the language of chemistry. So we can do a similar thing by taking computational components or ideas or numbers and putting them together and creating results. Now, the great thing about this notation is that when we take it to the next level, which is we provide a pool of say chemicals, or a pool of components, and we kind of react them together, we can really create a lot of different results. And so comes into play with combinatorial kind of explosion of different possibilities, and we can create different chemicals and different results. It's similar to the way you would say, over time simulate a system that kind of reacts to certain rules. So it's the same thing, but the idea is communicating or setting yourself up with this notation to take chemistry and create algorithms around this notation that work on chemicals. So, I hope that really opened your eyes. But that's really essentially it. That's all artificial chemistries is. We're taking this idea of computation, we're applying a different notation to the system, providing certain rules, and then putting it through an algorithm that does certain things to create the results and outcomes. So we don't necessarily always know what the results will be, or that's the whole point, right? We will create a system and then observe the result. So guys, that's really the first introduction to artificial chemistries. In the next video, we're going to talk about how we can structure the system and basically provide some structure around how we take this notation and how we can provide it, and how we can build on it to build a system that will then give us the ability to create artificial chemistries. So guys, I will see you in the next video. This is just a quick introduction. I'm doing it bit by bit, so as I'm learning stuff, I will do a video on it. Guys, I'll see you soon. Bye.